No.
Yeah.
Maybe.
Yeah,
Yeah. That.
You're several pages wrong. Okay. So example 4 starts us off. Suppose those new Bluetooth headphones from example 3 sold for $125. So it'd be $125 per pair. Okay, so first of all, write the revenue function. Well, revenue is going to be R of X. What's revenue mean?
Was it the C of X over X? Or?
No.
No, that was the line.
This is, there's not really a formula. This is just you using your smarts about how we write an equation for revenue. How would we find revenue? What is revenue?
It's the money earned.
The money you earn. Okay? How much are we earning?
125 per thing.
125 per thing. So what am I going to write? 125x. Thus, there's not really a formula. It's just revenue is the cost of the item times however many items you're selling. Okay? Write the profit function. Now, remember, there is something about profit there, I believe. Profit, we use pi of x is what they suggest. Although you do see p of x sometimes for it. And if you look back, it does talk about profit. In order to profit, I mean, it's logical. You're going to take your revenue, the money you bring in, right? And you're going to have to subtract off your cost, right? Because your profit is how much you bring in minus your cost. Well, what's my revenue? $125x minus, what's my cost? My hint is go back to example 3. This is not something you're creating. This is something that was provided.
Oh, this is from, carries over from example.
Yes.
Okay.
I had no.
I didn't know it was the same problem.
It
Yes.
said example 4, so I don't know.
But it says, suppose those new Bluetooth headphones from example 3.
Oh.
Okay, so cost function is provided, yes? Cost function, so we're going to be subtracting. Just lost it. The quantity. This bin queue is going to have to be restarted. It is doing weird stuff. 1500 plus 50x plus 100th x squared. Could we technically clean that up a little bit?
No. Yes.
Technically. I said technically. So technically I could clean this up and say, let's see. This is supposed to be 125x, isn't it? Question me on it, Maddie. Come on, question me. Mrs. Sargent, why is there no x on your revenue? And my answer would be, I don't know. Okay, so if I go, do I want to go, I think in the book I have reverse order. So if I put the negative 1500 first, 125x minus 50x is going to be plus 75x, and then subtracting 1/100th x squared. Something along those lines, right? Reverse it if you prefer. Okay, C. Marginal revenue. Marginal revenue is not defined in the notes I discovered. But, okay, what do you know about marginal cost in comparison to cost? It's derivative. So what's marginal revenue? Derivative of revenue. And what is the derivative of revenue? 125. D. Compute the marginal profit function if 100 sets of headphones are produced and sold. Interpret your findings. Okay, so marginal profit. How do I do marginal profit? That's going to be the derivative of profit, right? Derivative of profit, so if I take my profit, negative 1,500 is gone. Derivative of 75x is 75 minus 2 times 100th, so 200's x, right? Compute the marginal profit of 100 sets of headphones. So that means we're going to plug in. We're going to do pi prime of 100. So 75 minus 200 times 100. Two hundredths times 100 is going to be 2. 75 minus 2 is going to be 73. Darn, I didn't mess up my math. And this is marginal profit, so that's going to be $73. How do we interpret this? That's been a big thing lately, right? Putting it all in words. When 100 headphone sets are produced and sold, right? What's happening? If nothing else, just think this is the derivative of profit. What do you think?
Profit is increasing $73 per set.
Yep. Profit is increasing. The only other word I had in there is at a rate of $73 per set. Not necessarily, you know, he's got increasing, so. Okay, when 100 sets of headphones are produced and sold, the profit is increasing. At a rate of $73 per set.
I don't understand like the first part of that sentence. Like, why do we have to put that in there?
When 100 sets of headphones are produced and sold, that's just the terminology of the original problem. I mean, you could easily say, you know, because the question was compute the marginal profit if 100 sets of headphones are produced and sold. So you could easily say, if they would have just said, you know, produced or just sold, you wouldn't necessarily have to have that whole thing. I mean, I could almost just say, at 100 sets of headphones, the profit is increasing. Okay? I mean, it's just using the exact terminology of the stem of the problem, which is good. Okay? It is good to keep with the same terminology that is in the stem of the problem, if that makes sense. Okay? And I think we have one more part. How many headphones should the company produce in order to maximize their profits? How are we going to maximize profit? How do we find max points? Like if we take this out of context of this problem here and out of all the business world context, just how do we find maxes in calculus?
Find the highest point.
Find the highest point. And how do we find the highest point? Don't think graph here.
Tangent line is
Okay, when tangent line is equal to 0, which means what needs to be equal to 0? The derivative equal to 0? You know that, right? We've done that, okay? maxes and mins, you find by looking at when does the derivative equal 0. Okay, it's the same idea. Well, I guess I don't want to use that example, but if we want to know, in order to max profits, you look at when does the derivative equal 0. Okay, so we're going to look at pi prime of x equals 0. My derivative was $75 minus 200 x equals 0. So I'm going to have 200 x equals 75. And I don't know, 75 divided by 200 is something. So 3,750. So how many headphones should the company produce in order to maximize the profits? The company should produce 3,750 sets of headphones to maximize profit. Do I need to write that out? I don't know. Okay. We have a graph to look at the bottom of this page. So we have all the information we need here. Okay, in that graph down there, notice the break-even points. You know what it means to break even? If you're a business owner and you're breaking even, yeah, you're making back what you spent. You're not losing money, but you're also not making money, right? Your costs are equaling your revenue, and there is no profit. So you'll notice here that the break-even points occur where revenue equals cost. And so here we have a, excuse me, it's revenue and cost together. Revenue being represented by the parabola, cost being represented by the line. Notice right here where revenue and cost intersect. Those are my break-even points. Not making a profit, not making a loss. Okay. Company would obviously be most interested to know how to maximize profits. The maximum profit or minimum profit can occur where MC equals MR. Excuse me. So where your marginal cost equals your marginal revenue. Excuse me. Or derivative, right? Derivative of cost equals derivative of revenue. However, maximum or minimum profits do not necessarily have to occur where MR equals MC. This is hugely important right here. They can also occur at endpoints. There are several examples as we proceed where we need to remember to consider endpoints, not just where marginal revenue equals marginal cost. Okay? And we will look at some of those. Consider the slopes of the tangent lines. Then when marginal cost is less than marginal revenue, a company will make more in extra revenue than it will spend in extra cost by increasing production. I have to process through that for a moment. So consider the slopes of the tangent lines when marginal cost is less than marginal revenue. And realize the slope of the tangent line for the cost function just is the cost function, right? With your revenue, that derivative is changing all the time. But they'll make more in extra revenue than it will spend in extra cost by increasing production. And oh, there's a graph in homework that talks about it. That's what it was. So you'll notice when we talk about, well, you're realizing here, revenue is up above. This is where your profit section is. Down here and over here, this is where our non-profit is, our loss is. Break-even points are where those switch. And yeah, I don't really have a whole lot else to say about that one. I think we may refer back to this if I recall. Okay. I think I'm ready to look at the next example. An office supply manufacturer produces spiral notebooks for interactive student notebooks. Find the quantity X that maximizes profit if the total revenue and total cost are given in dollars. So in other words, in order to find maximize profit, it kind of depends on what you're given, right? We don't have a profit equation here, but we have a revenue and a cost equation. So where notebooks are between 0 and 1,000, what production level gives the maximum profit? So what did we just read on the previous page? Maximum profit can occur when? Marginal cost equals marginal revenue. So what do we need to start off finding? Yeah. Marginal revenue, marginal cost. Oh. We'll end up with the same equation. Okay. Connection just made. Thank you to the birthday boy. Okay. Huh? Jacob started to say something about going a different direction with how we were going to do this problem, and it just made a click for me. Okay, so maximum profit. What did we just do? Sorry, you guys aren't in my head. You guys don't understand where I'm going with this, maybe. How did we just find maximum profit a problem ago?
0.
And what do we equal to 0?
Derivative?
The derivative of the profit, yes? How did we find said profit equation? Revenue minus cost, yes? Okay. So, on this problem, I'm going based off of what we just talked about, that we're going to want to set marginal revenue equal marginal cost. So we need to find the derivative of revenue, the derivative of cost, and set them equal to each other. Well, the derivative of profit would be the derivative of revenue minus derivative of cost. So we'd end up with the same equation if instead you went the idea of, oh, I have revenue and cost, I'm going to find the profit equation and then take the derivative. Okay, maybe not. I see where I'm going with this. So the idea that profit is revenue minus cost, right? And so then the derivative of profit is the derivative of revenue minus the derivative of cost. So the idea that this would be marginal revenue minus marginal cost equal to 0. But we're going to have marginal revenue equal marginal cost on opposite sides of the equation. So the idea that here, if you try to set this equal to 0, then you can add that over and you can have the derivative of revenue equals the derivative of cost. It was just the connection my brain made. Cool in my brain. You guys, I think, could care less, but that's fine. Okay. Marginal revenue. What's the derivative of revenue? Eight minus 8 thousandths x. Marginal cost. What's the derivative of cost? $1.2 if I'm looking at my math correctly. Based on what we were just looking at the other page, when does max profit happen? Max profit happens when marginal revenue equals marginal cost. So what am I going to do in terms of the equation? Set them equal to each other. I'm going to say 8 minus 8 thousandths x equals 1.2. And I'm going to work my way through the math. Negative 8 thousandths x equals negative 6.8. Whatever 6.8 divided by 8 thousandths is. And so our max profit happens when we have 850.
How would you do it if you went the other way? Because like you do.
You would have done this way?
Yeah. Something like that, yeah.
I mean, your profit equation would have been revenue minus cost.
Mm-hmm.
So 8x minus 4 thousandths x squared minus the 700 and minus the 1.2x. Then you take the derivative of that. So you'd have 8 minus the 8 thousandths x minus 1.2x. And then to maximize profit, you'd set equal to 0 to look for max in minutes.
Okay.
And you'd end up with the same equation then. Okay. What production level gives the maximum profit? And what production level is that? 850 notebooks. Now, that's all it asks right there, isn't it? I must have looked at the answer key and there was that, direction there. I'm not going to take my time to go through all that. They do some check work in the notes, if you look at the notes key with all of this, but I'm not going to take time to do that. I am curious, though, what will the max profits be? How can we find the max profit? Okay. Okay, so take 850 and plug it into R minus C to get your profit, right? Or in other words, plug it into revenue, plug it into the cost, and subtract them. Okay, so I'm just going to say, I want to keep us moving here, and I'm slowing us down. So max profit occurs at 850 notebooks. Okay. Let's go ahead and look at 6.
Yeah, here it dropped out.
Somebody dropped out?
Doc.
The dodgeball?
No docs out there.
Oh. Okay, example 6. The table shows cost and revenue for the production of a widget. Use the table to answer the following questions. So we have a table. X represents the production of a widget. How many units of widgets? R for our revenue, C for cost. What is the price of the widget? How are we going to find the price of a widget?
much money can they make on they sold.
Okay? Did you guys catch what she's saying? Revenue is how much you make. And if you know how much you sold, in other words, could you take the revenue at some point divided by the items sold at some point? Does it matter which pair of values I take? 600 divided by 200, 1200 divided by 400, 1800 divided by 600. Have I made my point? So the idea, if I just take 600 divided by 200, how much is a widget? 3. And that would be $3. We're assuming dollars just because it's revenue and cost. Okay? Yes?
What's a widget?
I was asking the same thing in my head.
Something they use in math problems, I feel like.
So all I can think of is the little widget things that are on our phones.
Well,
That's all I'm thinking of. Not to be confused with a gadget.
I'm sure maybe there's an official definition of what a widget is, but I just feel like it's some random. I used to feel like it's some random made up math term, but then you talk about, widgets on phones and devices, so I don't know. Okay. What are the fixed costs?
$800.
Why 800?
And when you sell none,
Yeah.
it's $800.
When you sell none, but yet you still have cost of $800. So rent, electricity, basic things that have to happen. Okay. At what production level X is the profit for the widget maximized? How would you like to do this?
Is it what, like, they equal each other?
What, in terms of revenue and cost?
That's not what that's not.
What would this point be here where revenue and cost equal each other? What is it?
Wrong class.
What did you say?
I said equilibrium.
Well, could equilibrium be another word for break even?
Yeah, sure. No, I don't think so. I think
No?
that's different.
That's
Okay.
more advanced.
No,
If you coat your head in squid, then yeah.
I don't know. Okay, so where your revenue and your cost are equal is your break even point, right? Now, I'm trying to look at how I did this, and I think I just kind of eyeballed it.
It's not 0.
I mean, like when you minus the 2, is that what it is?
Because I don't really have, if you look at it, when does profit happen? Profit happens when you take your revenue and subtract your cost, yes? We don't have functions to take derivatives of. And so your easiest bet here is to eyeball it.
800. Wait, no, not at all.
I disagree. I know, I was doing the math to double check myself here.
1,000.
1,000? Because if you look, the profit at 1,000 is going to be the revenue at 1,000 minus the cost at 1,000. So that's going to be 3,000 minus 1,850, which is some number I have written in my notes. $1,150. If you check all your other values, never will you get a value as big. So that is a max profit. Let me point out, that's at the end, yes? Do you remember when it said max profits could occur at endpoints or min profits? This is an endpoint. Okay, this is when we talked about, which page was it? Right here, maximum and minimum profits can also occur at endpoints. That's exactly what's happening here. This is an endpoint. Okay? And you've got that max profit happening. There's other profits along the way, but that's your max profit. So, explain your reasoning. Well, our reasoning was that subtraction, wasn't it? That's when the revenue is increased the most from cost. So I just have maximum profit occurs when production is 1,000 widgets, and that, you know, revenue of 1,000 minus cost of 1,000 is 1,150. So maximum profit occurs at 1,000 widgets.
Mrs. Sargent,
Yes.
I have a complaint.
Oh no.
I don't got time for this.
So at 1,000, you get the most profit, but like, is it the most profit or the most profit per widget? Because at 800 is the most profit per widget.
Ooh.
What?
See.
If you divide it by the amount of widgets sold, then you get more per widget.
But would it matter if it's?
I don't know if
My brain's not understanding how that's mathematically possible. It should be the same, but it's not. But wait, the cost, okay, wait, the revenue is always the same because it's always $3 per widget, but the cost changes, doesn't it? That is interesting thought. And we are looking at overall profit. So, I mean, you know, you always want to assume overall profit, but that is an interesting thought that, I don't know. Complaint voiced. That's all I got for me. That's all I got for you.
Alright. I'll take it.
You know, I will acknowledge your complaint, but I got nothing past that. Okay.
That he's an adult now.
Okay. When backpack production is $5,000, marginal revenue is $5 per backpack, and marginal cost is $465 per backpack. Would a maximum profit be expected to occur when production levels are above or below 5,000 backpacks? Okay, so I'm going to gather some information here. Marginal revenue at 5,000 is $5, right? Marginal cost at 5,000 backpacks was $465. Now, if we think about a graph setting, what are these $5 and these this 5 and this 465? What are marginal revenue and marginal cost on a graph?
Max and minutes.
No? What of this tangent line? The slope of the tangent line? Because marginal revenue is R prime. Marginal cost is C prime. So these values are slopes of the tangent line, slopes of the respective tangent lines, right? Okay, just have to get through next period and then I can restart this bin queue and hopefully it's being really glitchy. It's driving me crazy. So slopes of their respective tangent lines. Now, would a maximum profit be expected to occur when production levels are above or below? But what do we notice here? Here we know that our marginal cost is less than our marginal revenue, yes? So what's that going to tell us? Our marginal cost is less than our marginal revenue. That means the rate they're changing, yes? The rate the cost is changing is less than the rate the revenue is changing. So revenue is changing at a higher rate. Is that making sense? I'm trying to get it all out in words. Okay, marginal cost, change of the cost. Marginal revenue, change of the revenue. Marginal revenue is changing at a higher rate. So that means what's going to happen with your profit? We're going to make more, right? So we're going to make more with that extra revenue than we'll spend in extra cost. And so at that point, we're going to, because things are increasing, we're going to expect our product or our profit to continue to increase is what we're going to expect. Does that make sense? What I'm saying there? I don't have that all spelled out the best. I'm struggling there, I know. So yeah, so because of the increasing production, they should expect maximum profits above the 5,000 backpacks. Okay, so write down what you want. I'm going to write down a few things to help you along. So because marginal cost is less than marginal revenue, or marginal revenue is more, company will make more in extra revenue. Okay, company will make more in extra revenue than it will spend in cost. And so we would expect maximum profits above, or I'm going to say due to increasing production. How's that? Expect max profits above 5,000.
Is this a spend in cost at the end?
Yes. Sorry. I was writing fast.
No,
the BenQ is being really glitchy.
I just couldn't see it.
Oh, okay. So not even all my excuses there. It's Mrs. Sargent, you're in the way. That's the problem.
5,000 is the amount of backpacks being produced, right?
Yes. When backpack production is,
Bless you.
yeah. So I'm not saying expect a profit above $5,000, a profit above 5,000 backpacks produced. And that is not working very well, but yeah. Thus the importance of labeling, yes? I should not just be throwing 5,000 out there. Okay. The last page of examples are just focused on other rates of change problems. So we are taking it's not velocity acceleration, it's not the business stuff, it's just other rates of change. Okay? So, ready when you guys are. Number 8. Gabby is working on a project that watches the decline in great white sharks in the Atlantic Ocean. The function, S of t equals that, gives the number of sharks t years since she began working on the project. Find the rate of change for the number of sharks in the ocean after 3 years. What do we need to find, essentially?
A rock.
Although, I wouldn't say a rock.
I rock.
I rock. Okay. Because average rate of change would be using like specific values and kind of like the slope. I think of it as more like the slope formula. Instantaneous rate of change is when we use a function to do the specific derivative. So yeah, we need to find instantaneous rate of change, or basically we want the derivative, and we're going to evaluate it at 3. So S prime of t. 3570 is just a coefficient, right? So it's going to stay 3570 e to some power. What's the derivative of e to something? E to something. So it's going to stay 3570 e to the negative 2 tenths t times the derivative of the power, so the derivative of negative 2 tenths t, which is negative 2 tenths. Not that you really have to, but if you clean it up, negative 2 tenths can multiply by that coefficient, so it can multiply by 3570. So negative 714 e to the negative 2 tenths t. And then we want to know the rate of change after 3 years. So S prime of 3, that is fully a calculator problem at that point, right? You do that. I'm going to keep moving because we have a couple problems left to get through and we're running out of time. Okay, so negative 391.851, something like that, right? What is this? It's the rate of change of number of sharks in the ocean. So what can you say? The shark population is what? Okay. And why do we know it's decreasing? Okay, we got a negative rate of change, and so it is decreasing. The shark population is declining, is the word I used, at a rate of about, what is this rate? At this point, it's about 392 sharks. And when is this? After 3 years. So we could have said after 3 years. I didn't start that way, but I'm going to say shark population is declining at a rate of 392 sharks after 3 years. Okay, start reading B when you're ready. Omar uploaded a funny video of sugar gliders on his Instagram account. The video went viral rapidly. The number of views T days after Omar uploaded the video can be modeled by V. What is the instantaneous rate of change of the number of views 5 days after he uploaded his video? What are you going to do on this one, guys? Same as last time. Can I skip to 10? That's going to kill you guys, but I can't get 9 and 10 in. I'd rather talk a little bit at least about pieces of 10. Okay? So you would find derivative, evaluate at 5. Gotcha. 10. Let's get what we can done here. Use the following table of values for the number V of t. Read the information here. Gallons of water in thousands per hour H that are flowing into a retention pond T hours after a severe thunderstorm. Okay, so we got all that information, right? Our table has time, so that would be T hours after a thunderstorm. V is your gallons of water per hour. A, what is the interpretation of V prime of t? Well, it's a derivative, so it is your rate, your IROC, if you will. It's your instantaneous rate of change, right? Of, what is it the rate of? V of t, V over t, right? So it's your thousands of gallons of water per hour, right? Thousands of gallons of water per hour, T hours after the storm. Okay, and it's flowing into the retention pond. So, I'm going to put IROC here. You guys know instantaneous rate of change, yes? Of thousands of gallons of water per hour, and that would be after T hours. And that is flowing into, I'm just going to put pond. Okay. How do I estimate V prime of 2? And I'm going to say you have two options. We can either use those two pairs or these two pairs. There's not a definite yes of which you need to do it. It does say estimate, right? So we can either do V prime of 2 and we can do V of 2.5 minus V of 2 over 2.5 minus 2, or you can do V of 2 minus V of 1.5 over 2 minus 1.5. I'll write the answers down here. If you think about it in a way, they're kind of a big difference, really. 0.18 or 0.44. Okay. Now, explain that median context. Well, the 2 is saying after 2 hours. And the derivative of V is your rate of flow, yes? Your rate of the change of the volume. And it's 0.18 to 0.44, but what is this measured in? Gallons of water. So if you take 1800s and multiply by 1,000, we are looking about somewhere between 180 to 440 gallons of water are flowing there. It depends on which you use. Okay? And I know I'm going quick here, but I'm just trying to get you what I can. If it's not there yet, the notes answer key will be up. When does rainwater flow begin to slow down? And this is looking at your graph. 0.5, increasing, 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 increasing. You see how my volume changed? It'll then start decreasing. So sometime between 2.5 and 3 is when that is happening. And estimate the instantaneous rate of change. So in order to do that, I did V prime of 3 by doing V of 3 minus V of 2.5. Using those two pieces there because that's specifically when we started to slow down. Okay? That ends up being negative 3.8, which is approximately negative 380 gallons per hour. Okay? And so,
Is that the V? Is that the rate that it's flowing at? The derivative?
yes. So yeah, so it's 180, somewhere between 180 to 440 gallons of water are flowing into the retention pond. So that's whatever gallons of water, I should say per hour. I didn't get the per hour on there. Okay, did I actually kind of finish? I guess I had a moment more than I thought. Okay,